So last time we talked about incidence and prevalence, right? And attack rate. So these kind of epidemiological indicators actually indicate how much we are mostly likely to get disease or something like that, right? How much we have a chance to get this kind of a disease or something like that. But today we are going to talk about mortality rate. It's like kind of indicator of death from a disease or something. So a mortality rate is a measure of the frequency of occurrence of death from disease in a defined population during a specified intervals. So we're gonna talk about many different types of mortality rate, like annual mortality rate, age-specific mortality rate, and sex-specific mortality rate, or case factor proportionated mortality rates or something like that. So we are going to learn about different types of mortality rate. So mortality rate, again, is an indicator of how these diseases are dangerous if someone's get a disease. Dangerous means like kind of death, die from this disease or something like that. Okay? Yeah. So first of the mortality rate, the first of the mortality rate is annual mortality rate. So annual mortality is actually indicator of the all deaths from all disease. So it is kind of overall comprehensive mortality rate, right? So the formula for this annual mortality rate is a number of deaths from all causes in 1 year over number of person in the population at mid-year times constant. As you know, the constants will be given like kind of per 10,000 people, per 100,000 people, these kind of things, right? Yeah. So that is the annual mortality rate. Number of deaths from all causes in a year and over number of persons in the population at mid-year times constant. Okay. So in the next slide, we had a practice question for this annual crude mortality rate. I will give you 1 minute and then you can actually work on this one and then we come back and then work together. Okay. Yeah. Okay, so let's work together. So annual crude mortality rate. The formula is actually total number of deaths over total population and times constant, which is the 1,000 people here. So total number of deaths from this example, how many people actually die? So here, a city contains 25,000 men and 35,000 women, and 300 men and 250 women die per year. So this is the total number of deaths, right? So 550 over total number of populations. So this is the total number of population. So 60,000 and times 1,000, right? So we get 9.17 per 1,000 people, right? So we got this number for the annual crude mortality rate, right? Yeah, very good. Okay. So the next type of mortality rate is age-specific mortality rate. So age-specific mortality rate is actually we narrow down a certain age groups. So number of deaths from all causes, but only age-specific age groups. It's not a total population, only one age, specific age groups, okay? Total number of deaths for a specific age group over total number of populations for actually also same the specific age groups. So in this example, those 65 years old, so we actually need to have information about the total population, number of total population for these specific age groups, 65 years and old. So that is the age specific mortality rate times constant. Okay? Yeah. So please keep that in mind. Just to narrow down all deaths from only one specific age groups, right? Yeah. So please keep in mind this for the age specific mortality rate. So here is the practice questions. Calculate mortality rate for age 20 to 29 for both Portland and Corvallis. So we actually narrow down one age group, which is 20 to 29, right? Yeah. So for both Portland and Corvallis. So how many people actually die for this age group in Portland and Corvallis? Actually 12, right? And 3 here. So 15, right? And times total population for this age group in this both city, 1,000 and 5,000. And so that's why 6,000. And times constant 1,000. So you got 2.5 point per 1,000 people, right? So that is the age specific mortality rate, especially for age 20 to 29. We can calculate the ages group only 40 to 49 here, right? So 9 plus 29, so 34 over total population, 1,000, 3,000, 4,000, and times 1,000, so something like that, right? So that is the age-specific mortality rate, okay? Okay, yeah. Also, we can calculate the age more than 50 years old for only Corvallis, right? So here, only Corvallis, 50 over 5,000 and times 1,000, right? 50 thousands and times 1,000. So you got 10 per 1,000 people, right? Yeah. So you got this number, right? Yes, good. Okay. And then the next mortality rate that we are going to talk about is cause-specific mortality rate. So cause-specific mortality rate, actually number of deaths from a specific disease. So we actually narrow down number of deaths from a specific disease. For example, here, lung cancer, probably we can have another example like kind of cardiovascular disease or like kind of car accident, like kind of a thing. something specific disease, right? So number of deaths from a specific disease over, and then we're not gonna narrow down this total number of people for this disease. Okay, so we actually use, instead we're gonna use the total number of populations. Okay, and then times 1000 times constant, right? So a specific disease, number of deaths from a specific disease over total populations. Okay, so we actually moving on to the practice questions. Here, calculate cause-specific mortality rate for lung cancers. Lung cancers. So we need to know the total number of deaths from all the diseases, right? How many, no, from the lung cancer, right? How many people actually died from lung cancer? Here, there were 20 males and 5 males case of lung cancer per year, of whom 12 males and 1 male died. So we need to have these numbers. So 13, right? Total number of deaths from lung cancer, 13. And then we still use the total populations, right? So this number, so 60,000. So, and times constant, 1,000 people. So we got 0.22 per 1,000, sorry, 1,000 people, right? So we got this number for cause-specific mortality rate for lung cancer. Okay, yeah. Okay, okay, good. So the next mortality rate is case fatality rate. It is kind of similar to cause-specific mortality rate. So we still use this number of deaths from a specific disease. So this is the same, okay? So this is the same, but the bottoms are actually different from cause-specific mortality rate. So cause-specific mortality rate, we use the total population, but case fatality rate, we use this. The number of people with the specific disease. So here, for example, lung cancer, the disease is lung cancer. So number of people with lung cancer and times 100. 100 means actually we're gonna use this present percentage, not a per 1,000 people like kind of constant, okay? So case fatalities present with percentages, right? So number of deaths from a specific disease over total number of people with that specific disease. Okay, yeah. So the denominator is a limited dose with the disease. It's a measure of the severity of the disease, right? Yeah. Okay, so we're gonna working on this. So in this example, we need to calculate the 3 different types of mortality: annual mortality rate, the cause-specific mortality rate, and case fatality rate. So I will give you 2 minutes to working on this. Okay? Okay, let's work on together. So annual mortality rate. So total number of deaths over total number of people and constant, right? So we actually remember the formula. So here, what is the total number of deaths? So here, 60,000 deaths occurred during the year ending December 31st, right? So 60,000 total number of people, actually 6 million people, right? Total population. So we can get this one like kind of 60,000 over 6 million and times 1,000. So we got actually 10 per 1,000 people, right? Yeah. Okay, good. And causes face-to-face mortality rate. So total number of deaths. So we can still use the total number of deaths, mortality rate from cholera. So specific disease cholera here. So how many is actually people die from cholera here? These include the 30,000 deaths from cholera. So we need to use these 30,000, right? And total number of populations, we still use the total number of populations actually 6 million, right? Yeah. And times 1,000 people. So we got actually 5 per 1,000 people. And then case fatality rate. So case fatality rate is actually for certain disease, right? So number of deaths for cholera, we still use the 30,000, right? Yeah. Over, we need to use the population, total population or not? No, right. So we need to use the total number of people with that disease. So how many people actually sick for these choleras? So 100,000 here, right? 100,000. So 100,000 and times constant? No, we need to use the percentages, right? So 100. So we got 3 percentages, right? Yeah. So that is the case fatality rate. So depending on the types of mortality rate, we need to use the different informations, right? Yeah, so we actually please keep in mind what kind of information we need to use for a specific mortality rate. Okay, yeah, very good. And then the last mortality rate that we are going to talk about is proportionated mortality rate. So proportionated mortality rate actually number of deaths from a disease, it is kind of the same thing, specific disease, and over total number of deaths, number of total deaths, okay? So number of deaths from a specific disease over number of total deaths and times 100. That is the proportionated mortality rate. So proportionated mortality rate, as you can see, this is the kind of proportions. So like kind of lung cancer, how many people die from lung cancer, and then how the lung cancers like kind of percentage, how much is a percentage among all disease, all deaths from all disease or something like that. So that is the kind of proportionate mortality rate. Okay, yeah. So calculate proportionate mortality rate for lung cancer. So number of disease from number of deaths from a disease. So here, 13 people actually died. And then over total number of deaths, right? So these numbers, right? So 13 over 550 times 100. So we use the percentage, the 2.36 percentage for lung cancer proportionated mortality rate. Okay, yeah. Okay. Okay. So let me briefly more talk about this proportionated mortality rate. Okay. Okay, so let's talk about the characteristic of proportionate mortality rate. So please look at these tables. Please look at the mortality rate for cancer, early period and later period. So here, cancers, actually 20 people die from cancers, almost 1,000 people. Then 20 people die, and also almost 1,000 people later period and early period. It is kind of same mortality rate. This is a cause mortality rate, right? Cause mortality rate. But look at the proportionate mortalities. So early period, proportionate mortality rate for cancer, 25, and then later period, 16.7. Mortality rate for cancer is the same for both early period and later period, but proportionate mortality rate is different. Early period is 25% and later period is 16.7. So based on these informations, cancer early period is more dangerous risk than cancer than later period. So probably if you actually answer this question based on this mortality rate, probably same. But if you answer this question based on proportion mortality rate, probably you say, okay, cancer in early period is more risk than cancer than later period. This answer is correct or not? Let's look at the next slide to get the answer, okay? Yeah. So here, so we 25 here and 60.7. Why this made this difference? What made this difference? Actually, did you remember the formula for proportionated mortality rate? So proportionated mortality rate is actually death from a disease, right? Over total number of deaths, right? So that is the formula for the proportionated mortality rate, right? Yeah, right? Yeah. So this is the proportionated mortality rate. So death from a disease, 2020, same. But this made a difference is because of this total number of deaths, 120 here and 80 here. So 80, 20 over 80 times 100 is actually 25%. But 20 over 120 times 100 is 60.7. So proportionated mortality rate is actually depending on total number of deaths. This number, total number of deaths. So that's why proportionated mortality rate can be misleading because the magnitude depending on the deaths from all causes, total number of deaths, beside the condition being evaluated. What does it mean by this? This number, 25 and 60.7, does not indicate the risk of dying from a disease. Okay? These numbers does not indicate the risk of dying from a disease. That's the characteristic of the proportionated mortality rate, because proportionated mortality rate depending on this number, total number of deaths from all causes, right? Yeah. So that's why, although proportionate mortality can give us a quick look at the major cause of death, but it cannot tell us the risk of dying from a disease. Okay, so please keep in mind this. So that's why we need a cause-specific mortality rate or case fatality rate when measuring risk of dying from a disease, right? So we need to use a cause-specific mortality rate or case fatality rate when measuring risk of dying from a disease. If we use the proportionated mortality rate to measure for measuring risk of dying, that can be misleading because proportionated mortality rate depending on the deaths from all causes, right? Yeah. So please keep in mind this. So here is the one example of these questions. Annual cancer deaths in white male workers in 2 industry based on preceding information. So we only have this information. And it was concluded that workers in industry B are at higher risk of death from respiratory system cancer than workers in industry A. This is correct or not? Let's look at this. So they kind of conclude this risk of these deaths from this cancer, respiratory system cancers, based on this number, 45 and 33. Is this correct or not? So in the previous slide, proportionated mortalities actually cannot give us information about how much this is a risk of the dying from a disease, right? Yeah. So 33% and 45% of all cancer deaths and 33% of the all cancer deaths. This probably, yes, proportionated mortality rate. So 180 over 550 is actually 33. 248 over 550 is 45. So this number is a proportionated mortality rate. So proportionated mortality rate, it cannot tell us the risk of dying from a disease, right? Yeah. So this number cannot tell us a risk of dying from this disease, respiratory system cancer. So answer should be not correct. So here is the things. A, the conclusion reached is correct? No. The conclusion reached may be incorrect because proportion mortality rate were used when age-specific mortality rate. No, it's not a related age-specific mortalities. right? The conclusion reached may be incorrect because there are no comparison group. There is a comparison group actually. The conclusion reached may be incorrect because proportionated mortality was used when cause-specific mortality rate were needed, right? So the answer should be D, right? Yeah. So today we talk about the mortality rate. We actually talk about learn about the different types of mortality rate, annual, age-specific, and cause-specific, and case fatality rate, and proportionated mortality rate. And also we talk about the characteristic of proportionated mortality rate, right? Yeah. So we have some in-class questions. So in the next video, I will actually working on the review questions with you guys together. Okay? Yeah. Thank you.